So we have discussed sum, difference, and multiplication, division. So up to here, these are arithmetic operators. So it will there will be no much difficulty. And coming to division, modulus, we have discussed some points what's happening in this division and modulus, and these are or and outer logical operators. Wait a minute, let me open the test bench also. This one only. Yeah. So I've written a test bench for this. I've instantiated AB, sum, difference, multiplication, division, modulus, or out, and out, and I'm first initializing A and B, and after some time units, I'm giving A is equal to 001 and B is equal to 3 tick binary 001, and I'm displaying the values. Again, I'm giving the stimulus A is equal to 4 tick binary all unknowns and B is equal to 4 tick binary 01x, and I'm displaying these values. And we have already discussed much about what's happening here. If we give A is equal to 4 tick binary 01x or 3 tick binary 01x, and what's happening. If you have missed that, please watch recordings which are available on the YouTube. So let us not waste more time on this, and let's proceed further in this operators. So today we will discuss some more operators. We have some more operators like relational operators. Relational operators. So don't miss those previous videos. Those in those videos I have discussed very important points. So watch it if you have not watched it. So output we will I'll take one negation underscore out. This is one output, and I will have wait a minute, not negation. I will take less than operator for comparing. Less underscore out and output. I'm taking just for an example here. In the design I have taken A is of 4-bit, so that's why I'm taking, yeah, we are talking about design only, right? So just for example I'm taking 4-bit. There is no not necessary, you can take any number of bits. Greater underscore out. Just for an example I'm taking some width, you can take any bit of your wish. And I have another output greater or less underscore out, and less or greater underscore out. So first we will discuss about this relational operators, and we will discuss another operators. So I will assign this less underscore out is equal to, wait a minute, I will assign this less underscore out is equal to A less than B, and I have declared greater, right? Greater underscore out. And I will assign this greater underscore out is equal to A greater than B. And I will assign this less than or greater than out is equal to A less than or equal to B, and also another greater GRE underscore less underscore out. Sorry, it should be greater than or equal to out. This is less than or equal to out. Nothing in the name, just for avoiding confusion. greater than or equal to underscore out. Here it should be less than or equal to underscore out, and this is equal to A greater than or equal to B. So less than, greater than, less than or equal to, greater than or equal to. And let me add this in the TB also, in the instantiation. So I am taking, let me add this in the wires also, less than LASS underscore out and greater than underscore out and greater underscore out, and we have um, less underscore equal out, less underscore equal underscore out, and GRA underscore equal underscore out. We should be careful because here we are doing a position based instantiation. That's why um, we should refer multiple times. It should be less underscore out, greater underscore out, less underscore equal to underscore out, and GRE underscore equal underscore out. Yeah, and I will display these values here. Actually, here there should be a doubt also. If you have referred the previous lectures or listened to these classes, then there should be a doubt which should be came already. Okay, if not came, no problem. Value of A less than B is percentage B, and it's equal to LASS underscore out, right? Yeah, LASS underscore out, and I will copy this, paste it over here. The value of A greater than B is percentage D, and it is equal to greater than underscore out, greater underscore out, and I'll also display A greater than or equal to B is percentage B, and it's equal to GRA underscore equal underscore out. Paste it over here, and this is equal to A less than or equal to B is equal to percentage B less than or equal to underscore out. Yeah. Let me save this and simulate this. So please try coding. So coding is very important. It is very greater than the learning theory. So we should do more coding if possible. 2 minutes still running. So at the console we can see, let me display this. So the value we have discussed up to here, or and so here if A is less than B, from here we have written our code today. So wait a minute. So if A is less than B, our value of A is equal to 1 and B is equal to 4. So A is less than B. That's why this operator is returning us 1, whereas our A is not greater than B. So it is giving us 0. And if A is greater than or equal to B, it is giving 1. This should be not true actually, but it is giving 1. And if A is less than or equal to B, it is giving 0. Wait a minute, let us check what's happening here. So for A is greater than B and less than B, it's correct only. And for A is greater than or equal to B and less than or equal to B, there is some issue here. A is greater than or equal to B and A is less than or equal to B. Yeah, we have written it correct. So the console, wait a minute. Where is my console? So we are getting A greater than or equal to B is equal to 1. Mm. And A less than or equal to B is 0. Okay, I will check it why I am getting like this. It should not be, it is not the correct output because A is not greater or not equal to B, but I am getting 1. Why the simulator is giving, why simulator is giving this, I am not knowing. Okay, let's see. And in the second case, value of A is fully unknown and B is 001x. So the value of sum is unknown. Difference we have discussed up to here. And sorry, I haven't displayed it here. Wait a minute. Let me add it in the test bench. Yeah, here let me add this. And let's see what happens if some unknown values are there when we are performing relational operators. Yeah, for A less than B we will get unknown, and A greater than B unknown. A greater than or equal to B is also unknown, and A less than or equal to B is also unknown if there is any relational operator performed between two numbers, and if there is an unknown in the two numbers, then we will get obviously unknown. So is this clear for everyone? This is clear, right? Yeah. So we will see equality operators. I will once check why I am getting for less than or equal to and greater than or equal to that particular output. If you know, you can comment, or else I will find it out and I will inform you. And for equality operator, equal underscore out, I will assign A is double equal to B. So for equality operator, we will use double equal to operator, and for k not equality, not underscore equality underscore out, I will use A not equal to B. And for case equality, we also have case equality. I will use triple equal to A. So we will check. So we will see what is meant by this case equality and equality now, and I'm using case not equal underscore out is equal to A not equal to. Let me add this in the port. Output equal underscore out. Output not underscore equal underscore out. Output case underscore equal underscore out. And output case underscore not underscore equal underscore out. This is what I have used, right? Case underscore, yeah. Let me save this, and let us fast include it in test bench also. So I have wires case underscore, sorry, first equal underscore out, wire equal underscore not underscore out, and case underscore equal underscore out, and case underscore not underscore equal underscore out. Yeah, and I will add here also equal underscore out, equal underscore not underscore out, and case underscore equal underscore out and case underscore not underscore equal underscore. And I will display the value. Let me copy one of the display statement and paste it over here. A double equal to B is percentage B and it is equal to equal underscore out, and A not equal to B is percentage B and it is equal to equal underscore not underscore out, and one more value, that is case equality. A triple equal to B is percentage B and it is equal to case underscore equal underscore out, and I will display another one, that is not equality, not case equality, and it is equal to case underscore not underscore equality underscore out. Let me copy this and paste it in another case also. So this is the second scenario. Push it over here and I will run this. Okay, let's check the output at the console. So if A is equal to B, since our inputs A and B are not equal, so we are getting A is equal to B, A double equal to B is equal to 0, and for A not equal to B we are getting equal to 1, and A case equality A triple equal to B is equal to 0 and A not double equal to B is also is 1 because they are not case equal also. And for the second scenario, that is A is equal to fully unknown and B is equal to 001x, we are getting equality as unknown because we cannot compare unknown with any other number. So equality operator cannot compare unknown with any number, and not equality also we will get unknown. And here we can see case equality we are getting 0. Since case equality can compare this unknown values also, here it will compare bit by bit. If this everything is matching, then it will give 1. Since it is not matching, it is giving 1. So let us change this number so that we can analyze this case equality also. It is equal to 0, 1x. So let's see what's the output of our case equality. So here we can see the output of our case equality is 1, whereas in normal equality we are getting unknown. Equality operator cannot compare two unknown values, but case equality operator can compare unknown values. So this is about equality operators. So this is clear for everyone. Can we move forward? This is clear, right? Can anyone confirm? Yeah. So let us quickly discuss about bitwise operators. So coming to bitwise and assign, I will take bit underscore and it is equal to A and B. So for bitwise and we will use only one ampersand, whereas for logical and we will use two ampersands. And assign bit underscore or, which is equal to A or B, and for bitwise negation, bitwise not, I will use not of B, and for bitwise XOR, I will use A XOR B. So I will include it in my port list. Output bit underscore and output bit underscore or output bit underscore not, and we have another output bit underscore XOR. So these are the bitwise operators. So try writing the test bench to this operators and analyze what we are getting at the outputs. So we can discuss this in tomorrow's session. I will write the test bench for that also, don't worry. But once you try writing the test bench and test with different stimuli, like I have tested here with a is equal to 001x or something, keep unknown values, and test with the bitwise operators, and we can discuss in tomorrow's meet. So if there is any particular doubt, you can ask me, or else we can end the session. Thank you.